Okay. Difference between physical and chemical change. What do we got? Okay, so with the chemical change, I have an actual change in composition. Is there another way to say that? Formula. So I get a change in the formula. So it goes from being like, I don't know, H2O to turning into hydrogens and oxygens. The actual chemical formula has changed. And the physical, just a change in state. Like a solid turning into a liquid kind of thing. Unit, definition for unit. Okay, I need standard. So it's a unit, we're obviously measuring something. And the standard part, what's important about that? Everybody agrees, everybody's on the same page. Why was the metric system developed? What do we got there? Pretty much to do this, right? To get everybody on the same page. They wanted to make one unit system for everybody on the planet to use. So they wanted to standardize the whole thing. And there was one other thing with that. So Earth-wide standardization and ease of use. They wanted to make a unit system that was simple. And it's simple because somebody said it over here. Because it's all base 10. So the value of the metric system is based on is 10. So really all I do is I multiply by 10 or I divide by 10. And that's it. Move the decimal place to the right, move the decimal place to the left. Nothing else to it. No 12 inches in a foot, remembering 3 feet in a yard, and 5,280 feet in a mile. All right, so decimals. What do we got here in decimal format for this first one? Zero, zero, I'm sorry, 0, period? 0? Do I want to put a decimal place there? I don't want to put a decimal place there. Why not? It's not that I don't need one. It's that I can't have one. I'm not allowed to have one. Why? No. I don't know the exact value of the last 2 places. So my significant figures are 4. How do I get 4 significant figures? There are 4 numbers there. So 4 significant figures. So my answer needs to have 4 significant figures. If I put a decimal place after the second 0, what happens? All of those zeros included are significant. That meant that when the person put this on the scale, it actually read 0, 0 as the last 2 numbers. And that's not the case with this. So no decimal place there. The next one? 10 to the 4? Okay with that? So when we're doing these, what we're saying is this number right here that we've got written and this number right here are now equal to each other, right? Those two things are the exact same thing. So how do I get this number over here, this 6.5895 to equal 65,895. I multiply by 10 4 times. That's it. Okay, decimal format for the next one. Okay. Why did we slide the decimal place the other direction? And a negative exponent means what mathematically? Divide. Whatever I have there, and in this case I have 10 to the third, right? So instead of multiplying by 10 to the third, I divide by 10 to the third. So instead of multiplying by 10 3 times, I divide by 10 3 times. Last one. Okay. So how about this converting inches into meters? So I'm going to start off with 285 inches. And I need to get myself to meters. So what do I need to use? I need to get through centimeters. So I'm going to put 1 centimeter or 1 inch is equal to 2.54 centimeters. What's that thing equal to? What's this equal to? 1, because those two things are equal to each other. So that fraction is actually equal to 1. All right, so I was able to cancel the inches out because I have 1 in the numerator and 1 in the denominator. So I need to move on to meters. So where am I going to put the centimeter unit? On the bottom again. So I'll put centimeters down here. And there isn't actually a conversion to go straight from centimeters to meters. If I have 1 meter, I got 100 centimeters. So then I can cancel out the centimeters. And the only unit I have left is meters. So it's 285 times 2.54, and then just divided by 100. So I get 7.239 meters. Is that my answer? 7.24. Why is it 7.24? I was only given 285. So that's only 3 significant figures. So my answer can only have 3 significant figures. So I'm going to have 3 sig figs, and that'll be the 7, the 2, and the 3, except there's a 9 behind it. So then I'm just going to go ahead and round up. So my answer is actually going to be 7.24 meters. Okay. So next one, we're going to convert feet into feet per second into miles per hour. So go ahead and start off with this 24.5 feet per second. So I need to get out of feet and I need to get out of seconds. So what do you want to cancel out first? Seconds? So where do I need to put the second to cancel it? Put it on the top. So if I have seconds here, can I get closer to hours by using some conversion? Sure, 60 seconds in 1 minute. That one's easy. And then I can cancel out the seconds units. And now I have feet per minute, so I'm closer. So then if I put minutes up here in the numerator again, I can go 60 minutes is 1 hour. And now my minute units are both canceled out. And I have feet per hour, which is better than what I had, but not quite what I want altogether. So I need to cancel out that feet unit. So feet goes here, and then what can I put up top? I can just go straight into miles. And for every 1 mile, it's 5,280 feet. And so then my feet unit cancel out. And then what I have left is the mile unit in the numerator and the hour unit in the denominator. So I get 24.5 times 60 twice divided by 5,280. So I get 16.7. And I got 3 significant figures in my given, and this was actually 16.70, so then it's just 16.7 for my answer. Okay, next one. So I want to use the railroad track for this. What's the volume of this piece of wood with this density and this mass? So I'm looking for a volume unit. So do I have a volume unit given? Somewhere up there? Milliliters up there, right? So I'm going to go ahead and start this off by writing 1 milliliter divided by 0.92 grams. Why did I flip the density over? I want the volume, and so I need the volume unit to be in the numerator. So I put it exactly where I want it. It came with the gram unit, and this value of 0.92 grams is equal to how many milliliters? 1 milliliter. So it doesn't matter if it's 1 milliliter equals 0.92 grams or 0.92 grams is equal to 1 milliliter. It's the same thing. 12 inches over a foot or a foot over 12 inches. It's still equal to 1. Okay, so I flip it over so I get the unit that I want in the spot that I want it. And then I'm going to take the other value that I was given, this 355 grams. Why am I putting it in the numerator? So I can get rid of that gram unit that the density came with. And so then when I'm finished with this, I get a milliliter unit. So I get 355 divided by 0.92. So I get 385.8. What's my answer need to be? How many sig figs? 3? So there's 3 for this 355, but there's only 2 right here in the 0.92. So I get to put 2 numbers down. So how do I write that? What's the most significant number in 385.8? The 3, right? 300. So that one's in. And what's the next most significant number? The 8, right? So the number after the 8 is 5, so it's going to round this thing up, and so it's going to be 390 milliliters. Do I put a decimal place after the 0? Why not? Because that would mean that that 0 is significant, and it is not significant. Okay. So let's convert 100 degrees Fahrenheit into Celsius and then to Kelvin. So before you do this problem, can you tell me about what the answer should be for Celsius? Really close to what? 37. Why? So I wanted you to know a few numbers that were Celsius numbers, right? 0, freezing of water, 100, boiling of water, 18, 19 degrees is room temp, and 37 degrees is body temp. So body temp in Fahrenheit is 98.6. And so this is 100, so that's pretty close to 98.6. So the answer I should get should be really, really close to 37 degrees Celsius. So if you didn't get that, then you did something wrong with your math. So what do I do with this? I take my 100 degrees, and what do I do with it? I subtract 32, and then what? All right, so it's really important that we do this. The subtract 32 needs to happen first. If I type that into my calculator as 100 minus 32 times 5 divided by 9, I'm not going to get the answer I want. Why? The order of operations is going to do 32 times 5 divided by 9, then whatever that is, subtract that away from the 100. And so if you got an answer that's not really close to 37, that's probably why. So I've got 100... So it looks like 37.7 repeating degrees Celsius. So how many sig figs do I have? 4. We're actually not going to deal with the significant figures yet. We do that when we're absolutely completely finished, because I need to use this answer that I have to calculate my next answer. And so how do I go from Celsius into Kelvin? $273.15, and then that's going to get me into a Kelvin value. So I've got so my answer for Kelvin is 311.28 K. All right, so how many sig figs do I have? 4. The 100.0. So how do I know that 100.0 is 4 sig figs? Who would write 0.0 if the thing they were looking at didn't actually say 0.0? So whatever the piece of equipment was, whatever the thermometer or the digital thermograph or whatever it is, it's actually giving me a value of 100.0 exactly. So that means I have 4 sig figs to work with. So then I'm going to write, for my Celsius, I'll write 37.78 degrees Celsius. And then for my Fahrenheit or Kelvin temperature, it's going to be 311.3 Kelvin. All right, so I have 290 Kelvin. And what do I need to do first? Yeah, just go backwards from what I did last time. So I'll subtract 273.15, and then I'm going to get a Celsius number. So 290 minus 273.15. I'm going to get 16.85 degrees Celsius. Okay, so I'm going to take my 16.85 degrees Celsius. I'm going to multiply it by 9 divided by 5, and then I'm going to add 32 to it. Do I need parentheses this time? When we did the conversion from Fahrenheit to Celsius, what did we do first? The multiplication and division or the subtraction? Subtraction. So if I'm going the opposite direction, what do I do last? The addition subtraction. So it doesn't matter. I put the multiplication in and it'll happen first, and then the addition will come up after that. So this is a 16.65 degrees Celsius. So what kind of Fahrenheit number would you expect? 60 something, right? 60, really low 70s, somewhere in the 60s, because we said room temp was somewhere around 17, 18 degrees. Okay, so I got this 16.85, I'll multiply by 9, divide by 5, I'm gonna add 32 to it, and I get 62.33 degrees Fahrenheit. So, sig figs, my answer, what should it be in? How many do I get? 2. That 290 is only 2 sig figs because there's no decimal after the 0. So I get to report 17 degrees Celsius, and I get to report 62 degrees Fahrenheit.
If you want like 3 significant figures of that, can you put a decimal behind the 0 and then no 0 behind the decimal?
If a person had measured this and the thermometer said 290 0 and there was a decimal there, then that's how you would do it. So 3 sig figs would just be a decimal there, and if I wanted 4 sig figs, I'd have to have a 0 behind that decimal. But for just 3 sig figs, I just throw the decimal down after the 0. What do you got for this next one about brief, non-scientific-y sounding name or definition for density? When you think about something dense, what kind of things come to mind?
How compact something is.
That's great. I like that. How compact something is. My little sister lived with me through middle school and high school, and we went on some vacations. And every time we went, I had like 1 duffel bag, and it wasn't actually really full. And she would have 2 suitcases. And what do you think those suitcases weighed? Do you think they were light suitcases? Do you think she was sitting on the suitcase to get them to close? Yes. So the density of her luggage was considerably higher than the density of my luggage because she compacted everything into that small luggage container. So that's all I want you to think about. How much stuff did I shove into this small area or volume? And that's going to tell you what your density is. Okay, this last one. So what unit am I looking for the density, or for just density? I need a mass unit divided by a volume unit, and that'll be a density unit. And so what I have here is a volume unit, this centimeters cubed, and a mass unit, this 240. So then if I just take 240 grams and I divide it by 268 centimeter cubed, my answer is going to give me units that conform to density units. And so 240 divided by 268, and I get 0.896. How many sig figs do I get? 2, because of the 240. So this one's a little tricky. What's my answer? .90 grams per centimeter cubed. So that first 0 doesn't mean anything. The 9 is significant. And why did I have to write the second 0? Because I had to round that 9 for the 0.896. I needed to round that up, and I needed to still show that I had 2 significant figures. And so writing that 0 after the decimal place, after a number, is showing me 2 sig figs. Okay.